Wait for it.
I'm waiting. I'm wearing my dev.life shirt too.
Awesome. That's great. So welcome, everyone. Thank you for joining us here on dev.life. My name is James Faulkner. I'm Liferay's community Tumblr and former community manager, now community Tumblr. If you're interested in why that is, ask me about it later. We have a great session today, but before we get to the wonderful world of Message Bus and asynchronous programming with Andrew, I just wanted to do a brief introduction if you've never attended a session before. What this is a regular Google Hangout. It hasn't been so regular the last couple of months, and I apologize for that. But we do regular developer Hangouts on Liferay topics for developing portlets or developing services or developing mobile apps or pretty much any development topic related to Liferay we'll cover here. If you're interested in interested in doing a session yourself and you want a super awesome, very exclusive t-shirt that you'll see in a moment, just contact me. You can always find me online on my Twitter handle or my email address, james.faulkner@liferay.com. Today we have a repeat guest, Andrew Jardine. He's one of our more active community members. Super smart guy. He's done a lot of work with Liferay, and I'm very pleased that he's able to join us today. So hello, Andrew. Are you out there?
Yeah, I am. Hi, guys.
Awesome. Yeah, thanks again, Andrew. And Andrew, he has developed various websites for Liferay, all using Liferay. He's done a lot of work in this area, so we're really happy to have him. So I think without further ado, we'll move on to today's session. So I'm going to hand it over to Andrew. And Andrew, if you can show us that T-shirt again, I'd really appreciate that.
Sure. Yes, I figure I should wear the uniform. So there you have it, and
yeah.
it fits me perfectly.
Awesome. Yeah, we're really happy that you did the previous session, and so let's get started with this one.
Okay. So I'm just going to start my sharing here. And then hopefully you can see everything now.
Yes, looks good.
Okay.
Actually, before we get started, if you have any questions for Andrew, we have an IRC channel. So if you've never used IRC, then you'll have to do a quick Google search on it. You can download clients and run them locally, and it's basically a chat room that started, I don't know, it's probably in the 80s they started doing IRC. And we'll be monitoring that channel for questions and answers. If you have any, you can just type them in, and we'll cover them as best we can. So anyways, back to you, Andrew.
Okay. So just before we get going, I wanted to run through a couple of slides just quickly, just to sort of lay the foundation for today, and then make a few points on a couple of things you're going to see. So this is the parallel processing using the message bus. I'm calling it parallel processing because that's kind of the way I see it. If you are a true concurrent programming individual, I might be using this term wrong, but hopefully I am not using it wrong. So the agenda, I'm just going to follow kind of a use case type scenario. So we'll talk a bit about the business problem, then we'll talk about how we would propose to solve this problem using Liferay, and then an overview of what we're going to be building to solve the problem, and then of course the most important part, the demo itself. So this is not an unrealistic business problem. I actually had this very same scenario with a client of mine very recently. And so what I'm going to show you is kind of a simplified version of how we solved it for them. But basically they had an application where users could sort of ad hoc request reports to be generated. And this was a sales tool, so they were client-facing reports. So having them generated in a timely fashion is pretty important. So the reports themselves encapsulated data that came from a whole bunch of different sources. Today we're going to try and we're going to simulate that in a way. And so what I've done is I've created this really horrible dummy REST service that we're going to call to simulate this process. And the REST service, I'll show you in a second, just does a 5-second pause. But the idea is that you might be trying to generate records or reports or something from data that comes from, let's say, a database or another system or a service that exists in the enterprise, so on and so forth. So in the case of my client, in the case of our example today, we're getting complaints where people are saying that we're suffering from really long wait times to get these reports generated, and it's impacting our business. So some analysis seems to point to the idea that some of the data sources seem to be able to produce results faster than others, and that part of the problem might also be that we are generating the reports sort of one at a time or sequentially rather than in sort of batch processes. So we have a proposed solution. So this is actually what we did. We sort of refactored the code to produce what we called parallel processing. And it was a two sort of step refactoring process. The first step was to create the reports so that the reports themselves were generated in parallel rather than one at a time. So imagine that a job runs, you're going to grab the latest set, which let's say is 10 or 20 reports. And rather than producing one report at a time, you want to produce 5 or 10 at a time. The second step, which we were able to do in our example, and we're going to look at today, is to actually refactor that further so that rather than generating one report per thread, we actually end up using a multi-threaded approach to produce the individual sections that go into a report. Now, to do all this, we're going to leverage Liferay's scheduler to kick off the jobs, and then the internal messaging capabilities to route sort of communication and get this work done. And in our specific example today, we're going to talk about asynchronous threading, so the sort of send and forget type model. And then at the end, now I kind of ran out of steam and time, so I didn't get a chance to fully flush out this last bullet as part of today's demonstration, but I can definitely walk you through what we did and how it worked. And that's basically how to reassemble the results after all these individual parallel processes are done. This is kind of the common problem with any concurrent kind of programming is state management and collisions in terms of who has access to records at what time, so on and so forth. And we're going to see today, as we go through the code, a couple of points where I'll just highlight, this might not be the best way to do it here because of these reasons, so on and so forth. But we don't want to make it too complicated because we only have sort of an hour and change to get through it all. Okay, so in terms of the overall, what we're going to see today, there's a sample, not same, I should say sample REST service to simulate the reporting actions. So this goes back to what I was just saying where you're going to call these disparate sources. We're just going to use one service to simulate this kind of process. We're going to create a client portlet, which is used to generate report requests. And that's really, this is just the boilerplate stuff to get started. This is kind of to get you to a point where you would probably already be in your application where you wanted to introduce parallel processing. So this is the first sort of section that you're going to see on that gist that's been shared. And I'm just going to rip through that pretty quickly so that we get to the actual purpose of this demonstration, which is the parallel piece. And then lastly, we're going to see some implementation of code that uses parallel processing based on the interfaces and structures that Liferay provides for us. Okay. Now, things that are not in scope, just so that everyone's clear if you come back to watch this video again later. The synchronous messages, we're not going to talk about that today. We're only doing asynchronous stuff. The callbacks from asynchronous processes we're also not doing. So, that's one thing I can talk about a little bit later, but you're not going to see it done in the code or on that gist. Maybe we can do that in another session. And also a discussion about different configuration options. So when you're configuring your messaging endpoints, there are different ways to do it. I'm just going to show you one way on how to do it today, which is kind of like a dynamic allocated or a lazy loading type model. Okay, so that's it for the boring presentation stuff. Now we're going to go right to the demo. Now, I had a little bit of trouble last night getting things started. Hopefully, we don't have any of those hiccups today. So the first thing I'm going to do, if you guys are following along on that gist, this notepad file, which you cannot read because it's in a tiny font for you, is the same thing as you see on that gist. So I'm going to be flipping back and forth between it often.
And by the way, Andrew, I just want to mention that gist, I put the pointer to that on the dev.life page, the upcoming sessions page for this particular session. If you need the link, I also put it in IRC.
Okay, perfect. And then the other thing that I should also mention quickly is I think on the page, James also added a WAR file for this project, which is called a dev.life REST service.
Yes, I did.
So I have that running on my machine in a, where is it? Here, in a separate Tomcat process. I didn't try putting it on the same Tomcat bundle as Liferay. I don't think it would work because I believe Liferay intercepts all the requests that come in and it wouldn't know what to do with it. But if you just have a vanilla Tomcat instance set up somewhere else on your machine, all you have to do is throw that WAR file into the web apps folder and start the machine up. It'll bind to port 9090, or sorry, it'll bind to port 8080. I've changed mine to bind to 9090 for the purposes of this demonstration. And you'll need to do the same thing if you're going to use the code from the gist. Okay. Other than that, I just have a Liferay. This is a 6.2 GA2 bundle running. It's vanilla. There's nothing special about it. And I'm using a MySQL database. And then for the service itself, if you're curious as to what the REST service has, it's nothing. It's basically, I just do a pause for 5 seconds. So we're really, this part is not the focal point of the presentation. It's really just to simulate a real world scenario where you would be calling something external with that you have a dependency on. Okay, so with that said, I'm just going to start right away into the stuff from section 1 of that gist. And the first thing we're going to do, like I said, is we're just going to create a plugin with a GUI and validate that our services and everything are working. Okay, so I'm not going to spend a lot of time discussing what we're doing in this piece because it's really not the point. It's a starting point that we need to have. So I'll create a new plugin project, dev.life report. I have some Maven profiles set up, so I'm going to point it to my 6.2 CE instance. And I want this to be a service builder portlet, which is an important piece. Okay, so first thing I'm going to do is I'm going to create my own custom portlet class. So inside here, I know you guys can't read some of the menus and stuff because they're probably too small for you, but really this piece is the only piece you really care about. And it's going to be a lot of cut and paste. So if you're following along, I'm on step 2. And all I'm doing with this particular class is I've defined some constants, and I basically have an action request, and the action handler. And the action handler is going to, once I have my service builder put in place, use the service builder code. Let me just get rid of this here because I don't have that. Or I will in a second, actually. Use the service builder code that is in place to save the request. So think of it as the user is coming to your application and saying, I need a report for client ABC. Right? So this is how they're going to make those requests. I'm going to update my portlet XML so that it knows about the class that I just created. So here. And then I believe I changed the display, Liferay display, so I could find it later. I just put it in a category called dev.life. And then I created some folders within the application to reference the structure of the JSP and the commons. So I personally, this is my personal preference. You don't actually have to follow this convention as part of your work. I just follow what Liferay does because I find it makes it easier to find things later on. So I get an HTML comment. In there, I create a file called init.jsp, and for it, I'm going to add this sort of boilerplate stuff that I normally include. I'm referencing here some JSTL stuff. We're not actually going to use it today, but in the steps I say you should add it. Like I said, this is all kind of boilerplate things that I do whenever I'm creating a new plugin because I invariably always end up using something from the JSTL library. Next thing I want to do is I want to create another init.jsp, but this time within the portlet folder itself. That just references, this one should be /HTML/comment, I think. So I think that might be a mistake on the gist. The init file that I'm adding inside my report request folder should actually reference the init file from the common folder. Oh, I'm sorry, I was correct in the gist. I pasted the wrong line. Last thing I'm going to do is I'm going to take the view that was given to me and move it into the report request folder. And then I'm going to change it to be the code from step number 9 from section 1. Okay, so what I have is a form. I'm going to allow my users to be able to name the report however they want to. And then they have a series of checkboxes. And the checkboxes would amount to the sections that they want to have generated as part of the report. So assume you're going to go see your client, and maybe you want to highlight for them, a summary, but then you want to really focus in on the cost versus the return on investment. You might only check those 2 boxes along with summary so that you get a very targeted report. You don't include sections like metrics, which might distract them from what you're trying to actually highlight. Okay, so just some more good practices stuff. I'm going to create a few more classes. They're going to hold values that we're going to reference in the code. So I'm going to make one for my web keys, which is essentially things that I pass to the GSP. I don't know that I actually use this one anymore, but now I think I missed something. Yes, package. Okay, and then I'm going to create another class which I'm going to use to store the status. So this is kind of an important one because whenever you're doing this parallel kind of programming stuff, you're going to need to make sure that you're referencing state and managing state correctly. Otherwise, you can get into a real mess in terms of your records in the database and things. And untangling that mess can be painful. So in our case, we're going to use a pending status, so a report that has been requested but hasn't been started yet, as a 0. Processing will be a 1. When it's complete, it'll be a 2. And if there's a problem along the way, we're going to update it to be a -1. Truth be told, I don't know that I was very diligent about making sure that this is perfectly done as we go through this process. Again, it was more about highlighting how to actually start parallel processes and things. But I think for the most part, I tried to adhere to it pretty closely. Okay, so now we're going to create our service definition. So in the service XML, I'm going to update it, and I'll just quickly go over what this is. You have the usual audit fields. We have some report details. And then most importantly, this is the section piece, right? So we're going to parallelize reports, but then we said we're also going to parallelize the individual sections. For now, I have a section summary status. It's really just to save myself a step later. But in the real world, if you were really just doing the first step where you're parallelizing, that's a tricky one, reports, you probably wouldn't have the actual section statuses. You'd probably just rely on the overall report status to determine whether or not it was done. But in our case, when we get to the next phase, this is going to be important because whether or not the report is done is really based on whether or not the individual sections are done and don't have a status of error. Okay, I think I just have a build service and deploy, or am I missing something else? Build service goal next. Okay, oh, my report request portlet is angry with me. That's because it's missing some stuff that I need for my build service. So we use the Liferay build service Maven goal. And should be pretty familiar to most people. It generates a whole bunch of code for us. And the last thing I want to do is I want to update my report request portlet code so that it actually uses the service builder stuff that we just generated. There's also a cheat in here that I'm going to tell you guys in a second. I think, is it in here? No, I haven't added it yet. Okay. Okay, so all we've done is we've, in our try here, is we've now said, okay, use the services we've built based on what the user has sent in, create a report, save it to the database, but make sure that it starts with a status of pending. Okay, so deploy the portlet and see that it works. So here's where the rubber hits the road. Liferay deploy. Looks good so far. If I go over to my screen here, I'll see that it's been deployed. It's ready for use. What I'm going to do is I'm just going to fire up my SQL as well. And then in a browser, sorry, I know I'm bouncing around a lot here, I'm trying to find all my windows. Where'd it go? Here we go. In my browser, I have my Tomcat running already. And I've created where I'm going to put my portlet. I'm just going to get this thing started. I cleared the work and temp folders. I did a dry run last night to make sure that most of these steps were working and we wouldn't have any problems to troubleshoot. And so this morning I cleaned all that stuff out. And one of the things I did was I removed the work and temp folders from Liferay. And so you guys are probably familiar with the fact that when you do that, it can be a little bit slow to start the first time as it recompiles everything. Okay, I'm going to sign in. I'm going to sign in. Okay. And then I'm going to, the portlet was here. It's been removed. So I will add it back. I have had a problem sometimes for some reason where the deploy target from the IDE doesn't always work properly for me, so I've had to use the command line, but looks like we're okay today. So if I add a test A, I'll check one of these, and I'll hit submit. It says it worked, and it looks like it worked. But let's check the database and see here. Tables. I'm going to find my dev.life table. And you probably can't read it, but I assure you it says test A for the report name, and there's a record. So we're happy with that. Okay, so my services are working. My portlet is built. Now what I'm going to do is, let's move this window over here, is I'm going to work on the next section, which is, we want to introduce a scheduled task. Right? So this is kind of like where we start. So, you could, of course, when the user hits the save button, put that straight into the message bus. In our case, we're actually recording it, and then we have a job that runs on a timed interval that will actually pick up the stuff. So I'm going to create a new scheduled task. And so to do this, I'm going to create a new class in my project, and I'm going to call it it's got the wrong name. So for you guys in the gist, it says report job message listener. It's actually report message listener, which you will see from the class name a little bit lower. It's an important distinction because we're going to actually configure something in the Liferay XML, or Liferay portlet XML rather. And if it doesn't have the right name, it's not going to work. So report message listener, the package is fine. And I've provided the implementation details for that class, at least to start. Okay, so this class is where we start to get into the meat of the messaging system. So when you run a job, a scheduled task, when it fires, what it does is it actually creates a message and puts it on the bus and sends it to the listener that's been registered. So to do this, you define your own message listener class that implements the message listener interface, which is provided by Liferay. The convention, at least from looking at Liferay source code, is that in the receive method, you in turn wrap that in a try catch and then call a private sort of do receive method. But what you get is a message object, and that message object will contain all the sort of payload information that you want to share with the actual listener that receives it. In our case right now, all we're doing is writing a logging statement. And I just want to verify that it works. This is kind of just the way I like to work personally. But so the first thing I'm going to do is I'm going to update the Liferay portlet XML. And in here, you'll see that I've added some scheduler information. So we've created a description for it. We've specified the class, which of course does not have job in the name. And we've set the trigger time. So in this case, this job, this scheduled task will fire on a 1-minute interval. There's different ways you can configure these two, but I think the scheduling stuff probably be another topic, not for today. Okay, so now one thing that I did find that caused a problem for me is that I have a very long name for my actual messaging class. You know, if you have a much shorter sort of package structure, then you probably don't have to worry about this. But there are a few configurations in the portal properties file that you can override in your portal ext file that allow you to control the max length. So when I first started working on this, I had a problem where my scheduled job wasn't firing, and I couldn't understand why. And after a little bit of debugging, I realized that the default max length for the name, which is, I can't remember what it is, like 80 or something, was too short to contain all the characters from my event listener class name. So a good idea would be to update your portal ext properties file with this information. The scheduler should be enabled already, but just to make sure, make it true. And I changed the lengths to be 255, just so that I wouldn't have any problems, when I create an even longer class name in the future. I've already done this in mine, so you can see here in my portal ext file, I've already had this, and I've already started my server, so it's already in place. But if you want to do that and just reboot your server in the meantime, that will get you back on track to where we're going to go next. So while you're rebooting, if you're choosing to do that now or later, I'm going to just deploy the portlet and validate that I see the do receive logging statement on a 1-minute interval.
Hey, Andrew, there's a question.
Sure.
Actually, it's a question from me. On the name length thing that you've just described.
Yeah.
Maybe you don't know, but is that related to the size of the field in the database? Because there are the model hints that you can describe the lengths of the fields for your custom services, but the scheduler is not your custom service, it's Liferay's. So I'm curious how that relates to the model hints settings for other portal or portlets.
Yeah, to be honest, I'm not sure, James. What I found was when it wasn't working is what I did was I dumped all the classes that were in the registry for the message bus, and it looked like this. The last 3 characters were missing, and so I think what I assumed was happening was it was trying to route to this class, but this class was not registered as a destination on the bus. So okay, it didn't get it.
So there's no entry in the database that has a field that's the name of your listener class. That's why the model hints can't be used to control the max size of that thing.
Right. Yeah, I don't think so. Okay. I didn't actually look, to be honest, but the registry I know is built kind of on the fly at runtime. So I don't think those things are read out of a table.
Okay.
Okay, so I've deployed the portlet version now that has just the logging statement, and if I look here, I can see that it is working because after it was deployed, I immediately have a message showing that the message listener has run. And you can see here's another one here. So it looks like it's working. So I'm happy with that. I'll just leave this in the background. It'll keep running on a 1-minute interval and keep logging, and I'll continue to make changes. So just a point right now I want to make, because we have this job running on a timed interval, unless you get the deployments done in the right synchronicity, sometimes you'll get into problems where you'll get some class not found exceptions. And what I suspect is some kind of collision with the work and temp folders that Tomcat uses based on the process is running already, and then you've tried to push a new portlet in because it doesn't actually block. So when I push my new portlet through, it doesn't check and say, hey, is there already a job from this portlet running using this code? If it is, wait till it's done. It just goes ahead and tries to mash it in there. But there's a few tricks you can use. Usually a server restart with clearing the work and temp will sort that out for you. But let's keep our fingers crossed that we can get our timing right and we don't have that problem. Okay, so I've got that done. I can see my scheduler working. I'm happy. So the next thing I want to do is I want to start actually calling my service, right? I want to see that when my job runs, the service that generates my reporting information is actually being invoked. Now, there's lots of ways you can implement a REST service call in Java. There's a million different libraries you can use. I chose RESTlet just because it, I don't know, was first in the search results. I have no real reason. I don't even necessarily use it properly in this example, but it's enough to make the call and get a response. To do this, we're going to update our POM, and the POM you want to update is the one for the dev.life report portlet module. And we're going to add first a repository in case you don't already have one for RESTlet defined, which you probably don't. And then the next thing we're going to add is going to be a dependency for the particular library from the RESTlet project that we want to use. In this case, it's the Java Standard Edition. That's what that is. Hit save. Now I'm going to update that report message listener class that we just made the target for the scheduled job to a new set of code, and then I'll just walk you through what this new set of code does. I think this is where I introduced the cheat. Close some of these down so I don't end up editing the wrong things. Don't need that, don't need that, or that, or that, or that. Okay, so this is what I'm going to replace. So the same thing as before, we have our do receive message that gets invoked. And then in this case, we're going to do, for this stage anyway, we're going to try and track some timing so that we can see how long some things take. And then we're going to loop over the reports. And then for each report, we're going to try and process it. Now, I added a method here called make reports. And this is this is the cheat that I keep referring to, because I don't want to manually enter 10 reports or 5 reports or any reports using the UI for the purposes of this tutorial. It'd be a waste of everyone's time. So I just wrote this quick little method that you would never deploy in production, of course, that essentially creates 5 reports or however many number you tell it to. In our case, we're telling it to make 5 at a time, and sets all the section attributes to true, and gives it a test report name of whatever plus the ID, and sets it to pending, and then saves it into the database. Now, the reason we are saying them all to true is because we are most interested in the time interval. So we want to make sure that all of our reports are the same, because if we have a report for the next stage that did not have the same number of sections as its sister report, then of course one report might take longer to produce than the other, and it's not necessarily because our parallel processing doesn't work, but more because the report itself is different. So we just want to make sure that we're comparing apples to apples, and so we're faking it essentially. So that list of reports then gets passed back here, and we loop over them, and then we update the status to be processing, and then we process the report. And then processing the report is essentially just calling this static URL. Basically, I'm not even clever enough to replace this with actual variables, because I don't really care, right? My service doesn't really do anything. It just pauses for 5 seconds, then comes back to me. So what I expect to see is 5 results or 5 records produced, and then this loop running and 5 individual reports processed. Just make sure I'm not missing anything. Yes. So I will deploy this again. I have an error, but it's in the init. Okay. Liferay Maven, Liferay deploy. And then a few seconds, it'll fire right away. As soon as you deploy the portlet, the job will run immediately. It won't wait for that 1 minute interval. But so you can see that we've made the 5 reports and we're starting to process them. The first one took 5 seconds, which makes sense. The second one will also take 5 seconds, the third, fourth, fifth, and we expect to see a total processing time of 25 seconds. Now, I mean, even if the individual report processing was down to 2 seconds at a time, that's not necessarily a bad reporting time, but it would depend on how many reports you're trying to generate, right? So going back to what I was saying, where this was actually a real world problem that we had to solve with one of my clients. They were trying to generate in the vicinity of 500,000 reports, and a report could take as long as 2 minutes to generate, right? So if you did the math based on how many they could actually produce without making the enterprise service bus catch fire, it ended up being that there was lots of cases where there was a threshold that they couldn't even generate all their reports in the month that they had, because they were monthly kind of reports, before the next month would start, and they'd have to start all over again. So of course, this is not an ideal scenario. We don't want it to take this long. So what we've got so far is we've got a scheduled job that generates reports in parallel as part of our portlet. So that's not bad. But let's go on to section 3 now, which is where we want to start actually producing the reports in parallel. So the first thing I'm going to do is I'm going to add this to my properties file. And I don't already have, I have them here, but they're not enabled. So I'm just going to uncomment them. And of course, for me to have these take effect, I need to stop the server and restart it, right? So I'll shut down. If you shut down at an inopportune moment, you will get lots of these problems. But don't worry about it. They're just things that Tomcat likes to complain about. Just to make sure I don't end up with any of these class not found exceptions, I'm also going to clean up my work and temp folders. Oops. Temp. And I'm also, just because I can, going to remove the dev.life portlet before I restart. Sorry, I forgot my recursive flag. And I'm going to restart. While the server is spinning back up, we'll go on to the next step. So I've added my new properties. Now, this is going to be a little bit more best practice stuff. I'm just going to create a couple of classes following the sort of convention that Liferay uses for the properties keys and properties values. So the first one, new class, is going to be my keys. And you'll see through closer inspection that this is essentially just a bunch of constants referencing the keys from my properties file that I just added. It's about to be in place as part of my restart. And I personally like the neat little trick that Liferay does, where they also have a values class to save you having to do the props util all the time. So I like to perform the same approach, new class, props values, and this class is just using the keys, but the props util, and then in the case of things that are not strings, we're also using the getter util to actually do type conversion to what we want to use in the code. The next step is we're going to have to create another message listener. Right? So the way we're kind of doing this is we're saying, okay, I've got this one process that runs and it goes over an array of individual reports and it produces them one at a time. But if I want to parallelize that, really what I want to do is I want to have multiple endpoints, like a pool of message listeners, where I can just send an arbitrary report into that pool and the next available listener will pick it up and generate the report. So to do that, we're going to basically have our scheduled job fire the report message listener, but then internally the report message listener is going to send messages itself to a different listener, which will be a pooled listener. Oops. So I'm going to create a new class. It's going to be used to manage those the actual report generation. And it's going to look very familiar. Oops, not that one. I want to create a class, new class. Because we're going to be using the same approach, this class is also going to be implementing the message listener interface. And in fact, most of what you're going to find in this class is almost a copy of what you see in the report class, but stripped out the pieces for handling multiple reports. So I still have in my class, I still have the implements the message listener. I still have my receive with my try catch for the do receive. And then in my do receive, I'm still going to time the start and end, but I'm not going to do the overarching process start and end because technically this class doesn't know anything about that. And then I'm going to use the this piece here. I've kind of hidden it in a subcall, but I'm going to use the getter util to retrieve a long, which is essentially a value that comes in this message. And so when I'm calling this message listener from my report message listener, when I put that message on the bus, I want to include the report identifier for the report that I want to actually be processed. So this get report method is going to basically use the services from the service builder implementation, retrieve the report, and then process it. And the processing part, which is right in here somewhere, it processes it. There. Sorry, I don't know why I couldn't find that. Is the same process method that we just saw in the other report message listener class. Okay, I'm still going to call the same service. I'm just going to do them in parallel now. So I've created a new message listener interface, and I've created the handler, sorry, for that. Now I need to update my report message listener so that it uses it, right? So that is what this piece of code here will do for you in step 6, section 3, I think it is. And then we can have a closer look. So copy, replace. Now, we still do the make reports. We still loop over the reports, but we have a send job method that we use now. The send job method, this is where we start to see a little bit more of this sort of asynchronous parallel stuff happening. Okay, so I'm using the API that Liferay provides for me to say, hey, can you check with the message bus to see if it has a message listener already registered with this name? And this is the name that we provided to it in the portal ext properties file, which was, in our case, dev.life /report_create. So we'll look for a listener with that name. If it finds one, then it says, great, I don't need to do anything. I'm just going to skip down here, and I'm going to create my message and send it. If it doesn't find it, what it does is it on the fly, sort of lazy load, I guess if you could call it, creates the message listener. So if you think back to when we first started this talk, I mentioned the different ways you can configure messaging endpoints. You don't actually have to do it this way. It is possible, although I'm not showing it today, to configure messaging endpoints using config files, XML config files. But I prefer to use this approach because it means I don't have to maintain that configuration file, and I only actually create the message destination if I'm actually using it. So if I disable this portlet, and the next time I restart the server, those destinations will not be there and will not be listening and won't be using any resources. But it's a matter of preference. I guess the downside is that this is done in code, so changing it's less intuitive, et cetera, et cetera. So if I don't have the destination registered with the message bus, though, then I need to create it. And to do this, for asynchronous endpoints, we use what's called a parallel destination. So I create my new parallel destination object. I set the name based on whatever I've configured in the properties file, and the same for the other values. The core size is basically the number of threads that will be created in the pool when the max worker size is the maximum number of threads that this destination will be allowed to grow in the pool. And then the maximum queue size, which is the number of requests that can sit in the queue waiting to be processed when these are all exhausted, essentially. Now, this is a very important step. Because the API has changed slightly within the last few versions, you'll see that this is actually the only non-deprecated way to do this. But this is an important step that needs to be done. You need to call this after property set method to make sure that the defaults that are created when you do the initial instantiation are overwritten by whatever values you specify. And you'll be able to tell very easily if it's not working, because if you were to inspect using JMX or something like that, the actual objects at runtime, you would see that the core size would be 3 and the max size would be 5. And that is an indication that your properties have not been applied. So call this, and that will make sure that it dumps the existing pool and recreates it using the values that you wanted. So then we add the destination to the message bus so that it's registered. And then we say, by the way, for these destinations, I want the messages to go to this class. Okay. Now, once that's done, again, we create a new message. We put in it the thing we know we want our receiver to be able to pluck out, which is the report ID. And then we set the destination name. You don't necessarily have to do this, but it's probably a good practice too. And then the last step, of course, is to use the utility class, again, that Liferay provides to send the message. Okay. So with that done, I think the next step is to deploy, and yes, and you should see things running in parallel. Okay, so my server is started up. Let's make a little bit of space here. This is going to happen a lot faster this time. So if I go right click, Liferay Maven deploy. Remember, we had that sort of 25-second lag where you could kind of slowly watch things dumping out onto the screen. But in this particular case, it's just going to flash through. So you see the reports were created, and then the jobs are retrieved, and they're processed, and it's done. Right? So within a 5-second interval, if I start from the top here, for 49 and it ends at 54, I have, in a 5-second interval now, I have generated 5 reports because I'm creating the reports in parallel. Now, I just want to take a second to highlight that really in terms of what I have done in terms of effort to be able to provide this parallel processing is next to nothing, right? I created a portlet and I put a simple UI on it. I used Service Builder to generate for me all the code that I needed to interact with the persistence data store. I made one configuration to have a scan in a 1-minute interval with one class with a very simple definition. And then I've created one additional message listener with a couple of lines of code, and I've created a thread pool that is managed for me where I'm able to provide parallel processing of this report generation. So really, on the whole, like Liferay has provided for me a lot of tools to get this work done without me having to really understand a lot about how to do concurrent processing. So that's great. This is definitely a big win. But if we go back to our use case, in the real world scenario that I was talking about before, one report could take up to 2 minutes. And there is, of course, going to be a limitation at some point in the number of threads that you can have running concurrently generating reports, right? So ideally, you would want to be able to generate an individual report as quickly as possible so that reports that are long running, like let's say there's 10 reports that take only 5 seconds, and then there's 4 reports that take 2 minutes, but you only have 5 threads. You don't want your long running reports to necessarily be blocking processes on the faster running reports being generated. So what you can do, and this is where it starts to get a little bit hairier, is you can start to, assuming the sections come from individual services or individual, let's say, data points, you can parallelize the individual sections of the report. Now, the complication, though, with doing this now becomes in terms of how you manage the state of a report. And we're going to look at that in the last section, and we're really just going to talk more about it than anything. I can try and show you the code, but I didn't quite finish that piece. So it might be more of a theoretical piece than a practical example. But so for the moment, though, I'm not going to worry about how I'm going to get my reports back together. I'm just going to worry about how I get these individual sections to be produced in parallel. So to demonstrate this, the first thing we kind of have to do is, and now we're moving to section 4, which is the parallel report section generation. The first thing we need to do is we need to reproduce our 5-second lag time for each section of the reports, right? So right now what we're doing is we're calling one service per actual report, but we want to be able to call that service multiple times within a report to show how slow it is for sequential section processing. So I'm going to create a new class first, because I'm going to be calling this service all over the place now. And I'm just going to put in this class the logic that we're using right now to actually call that dummy REST service that we've been using. Take this in here, and nothing's changed. It's all the same stuff. Call this static endpoint. The static endpoint pauses for 5 seconds, and you're done. Okay, we're done with that class, so I'm just going to close it. We're done with the POM. We're done with the portlet. Now we need to, again, create that slow report generation. So we're going to update the create message listener class with this chunk of code here. So create report message listener, I'll replace that code, and we'll just have a quick look. So I'm still going to do the get report. I'm still going to go and do a process, but in my process step, now what I'm doing is for each of the sections in my report, if it's enabled, which of course we know it is because we're setting them all to true, I'm going to call that service one time. Right, so I should go back now to saying I'm producing my reports in parallel, but it should take 25 seconds to produce my reports. I'm just going to stop my server and clean it and stuff just to make sure we don't have any problems. Shut down, and then I'll do an portlet out, and I will clean out those two things and start it up. And while that's starting, before I deploy this, we'll just have a quick look at what the next piece is going to be. Oh, I probably should have looked at that first. Okay, so we're expecting to see our 5 reports generated in a 25-second window based on our individual sections lagging. And then after that, we're going to add these properties. So we're going to have to do another restart in a minute to make sure that we get these properties in place as well. But these new properties that we're going to add are going to be used to control the thread counts and the pool max and min, as well as the queue size for the individual sections. So I'm sure you can probably guess by now what it is we're going to be doing next, where the same way we created multiple reports by creating a report message listener, we're now going to create individual message listeners for the individual sections of our report, and have the create report message listener, create messages and send them to those individual section listeners. Give this one more second. Should be almost done. I probably could have removed some of those portlets that I'm not using, but it's all right. Okay. I'm going to deploy this now. Liferay Maven deploy. And we should see the service kick off right away. Yeah, so you can see now we have the individual processing sections being done, right? And then you can see here, I should have highlighted this earlier, but these are our threads, right? So I can see that I've got a report create thread 2, 5, 4, all the way up to 5, and as low as 1. So I know that I'm getting the create report threads. Here's my create report message listener running on the different thread, which is called create, right? So I can see that things are working properly, and of course, testing the reports take 25 seconds to generate, right? Because of the 5 sections, 5 seconds a section, 25 seconds total. Okay, so now, I apologize, I probably should have done this sooner, but I'm going to shut down again. And then in my portal ext properties file, I'm going to enable those properties for my my parallel destination settings for the sections. And I'm going to restart. I won't clear anything out this time. I'll just restart it. And our fingers crossed that we don't have any problems. Okay, so I've added those things. Now, while it's starting to make these available, I'm going to update my create report listener class. Sorry, I'm gonna make a copy of it, and I'm gonna name it the report section summary message listener. Okay, so I'm going to copy that class, and I'm going to rename it to report section summary message listener. I'm going to open it up, and I'm going to change the definition to be this block of code here. And then we'll just have a quick look. So again, all very familiar. We have the message listener interface. We have our receive method. We have our do receive method where we're getting the report. And then we call the service, right? So in this case, we don't have a subtask that's happening. I've received a request for the summary section. I've retrieved my report, and then I'm calling the service. Now, even this report retrieval, this is where I was saying before, it gets kind of tricky, right? You have to try and envision. I don't know why I commented that out. You have to try and envision a scenario where in a multi-threaded application, you have one record in the database, right? So updating that record in the database becomes a little bit tricky because you want to make sure that a subtask, let's say for the metrics summary section or the metric section, isn't updating the database record at the same time as the summary section is retrieving it, right? So it can be out of sync. If the summary has retrieved it before the metrics has updated it, then when the summary commits its changes back in, you could end up overwriting something that was written by another process. So again, that is something that is tricky. In a second, we're going to look at how you can do some sort of reassembly. But for the purposes of today, just to keep it simple, we're going to cheat a little bit in terms of how we do this. So I'm going to, before I show you the cheat, I'm first just going to add some more properties and keys to those two classes that I created. So first, this one is, which one is this? This is the keys. So here, and then in the values, you can copy the whole class. I know it's just this piece, which is why I'm plucking it out. So this is just to highlight the things we just added to the properties file. And then I'm going to update the create message listener so that it actually uses our section summary. Now we have 5 sections, but we've only created 1 section summary so far. And the reason is because I want to make sure that it works before I reproduce these results for other sections. So I'm updating my create report message listener. And what you can see is here for the first one, which is the summary section, I have changed my process section, or I've added a process section method. And in that process section method, I'm specifying the section that I'm processing and the listener class that will be responsible for actually doing the work. So if I look at that process section method, it's very familiar based on what you saw in the create report, or sorry, in the report message listener, where we register the destination dynamically. Here we're doing it just a little bit differently because we're passing the class in so that we can reuse this method. And then I'm cheating by dynamically creating a destination name for the section. I mean, really all these things should probably be moved into constants or properties that can be changed more easily. But for the purposes of demonstration, it meets our needs. So we create, if it doesn't exist already on the bus, we register it, setting the properties as we did last time. We call that after property set. We add the listener class, and then we create our message. And this time when we create the message, we include not just the report, but the section. And the important part for that is, really for us is just the logging piece. But in the real world scenario, you would probably use that to determine which services to call. Now, you don't actually have to have individual section listeners, right? I could create one report section listener and have the logic in it be dynamic to determine based on the section that was passed to it, which external service it needed to call. It's kind of up to you. In our case, we chose to go with the individual section listeners just because we found that some needed higher thread counts than others. In some cases, some things had other dependencies that we wanted to make calls on that would delay, so on and so forth. So for our purposes, it made the most sense to have concrete section listeners. Okay, I think we're at a deploy step. Yes. So fingers crossed we don't get any of these class not found problems or collisions. Can we get in there? Yeah, see, this is one of those collision class cast. This is one of the problems I was telling you about. And I think it stems from a running process where you're trying to basically bully your way in. It's a very simple fix. It's just to shut down the server. I tried actually just removing the portlet, but depending on where the threads are running, it can be a little bit finicky as well. I haven't actually tried this yet, but there is, I noticed, a portlet in the marketplace. Let's see what I'm doing here for a second. That, okay, start. There is actually a portlet in the marketplace written by one of the Liferay partners that you can use to control jobs. So I'm not sure if that would somehow help. It might. Liferay marketplace. I can't remember what the name of it was, but I know it was one of the bigger Liferay partners that did it. Jobs. Yeah, this one. Right, Rivet. So I haven't actually tried this, but it looked like a pretty cool marketplace plugin where you could actually, you can't read that at all, can you? Where you could actually see the jobs that have been registered. So in this case, what it would probably show you would only be the report job. But one thing I could try after this and let you know how it goes is if you go in here and you were actually to pause the job before you did another redeploy, that might help with this problem. Anyway, it only takes a minute to resolve through a quick restart anyway. But of course, in a production scenario, you would not want to have to suffer through this. That's for sure. But what we're expecting to see when this is all said and done is, where are we at now? We're creating a parallel process for the section summary, but not for these other ones. So the reports will be generated slightly quicker. We actually just want to make sure that in the log, we see this particular class being invoked, and most importantly, that we find a thread called dev.life report section summary. If we do, then we know that the messages are being created, placed in the bus, and handled by a separate pool, and we can go ahead and reproduce this exact same process for the other section types that go into our report. I don't know why I chose 5 sections. I probably should have only chosen 2 to make this a little bit quicker, but I guess I tried to make it as realistic as possible, maybe. Okay, so our server's back up. I'm just going to redeploy this portlet. Give it a few seconds. And here we go. Okay, so I can see here my report section summary. So that's good stuff. And my timings, I don't think they show up anymore. I think I might have removed them all by this stage. The timings don't really make a lot of sense anymore because now this is where the kind of asynchronous callback stuff would come into place. But we do see 20 seconds for our processing time, which makes sense, right? Because I had 5 sections that were done in 25 sections. I've offloaded one section, so I'm left with 4. So the 4 sections that remain are taking 20 seconds to be produced. Okay, so I'm happy with this. What I'm going to do now is, just to make sure we don't have to do it in a minute, is I'm going to do the clean process and restart while we add the additional listeners. The next step is basically we're going to reproduce the same thing for all the other sections. So I can never remember all the names, but there's an ROI and there's a recommendation. So I'm just going to copy the report section summary message listener. I'm going to rename it our report summary ROI message listener. And then I'll make another copy. The next one would be called recommendations instead of summary. So report section recommendations message listener. And then I have a metrics. So report section metrics. And the last one is costs. So take this out of here. Costs. And fortunately, Eclipse is nice enough to rename everything for me. And because I have this as a very generic kind of implementation, I don't have to worry about changing those things. Each individual section listener will use the same thread counts and max queue from the properties file that we've already configured. And I think we just have to update this class now, create report message class. Yes. And really, it's just that one method. So I stopped pasting the whole class for this piece. We're just going to reproduce. We're going to, sorry, not reproduce, replace this here. Okay, and just having a closer look at it, we're doing the same thing we did for the section summary, or the summary section, but we're doing it for ROI, for recommendations, metrics, and costs, and we've referenced the classes that we've just created. And their internal definitions, of course, are the same. You should end up just seeing a different name in the thread executing it. So with this change in place now, what I expect to see is the full process again happening in a sort of 5 second or near 5 second interval. Okay, so I'm just going to do a deploy, and then we're nearing our academic stage. Deploy. Oh, I didn't save it. Yeah, I want to save it. So put this out. And you can see right away that like it registers in a 0 second timing to be done, because it just happens so quickly, right? So we can look closely at this. We can see the costs are in there. We can see it's probably up higher somewhere. Metrics. Yeah, summary is up here. I just saw it. Recommendations, summary. So the individual reports are being processed, or individual sections within a report are being processed in parallel. So you have this kind of a tree effect happening now, where when the job runs, it spawns off 5 create report processes, but then within each create report process, we've spawned off an additional 5 processes, 1 for each section. Okay, so now we're getting to the part where I'm not really sure I can demonstrate it fully because I ran out of steam trying to put this together. You can skip this first step because I actually used this, the service definition here is the same as we used in the beginning. Before, what I was doing was I was not putting the statuses in here and I was regenerating the services, but it's the same, so you can skip it. Where did I get to? Okay, so to solve the problem of individual the individual thread. So let's just look at one report for a second. Let's assume that my job runs, only one report is found to be processed, and it creates the 5 threads for each of the sections. Now, each section essentially is working with the report in parallel, right? So even though it's processing its own individual section, ultimately it's going to be updating the same report record. And this is where the collision that we talked about before can come into play, where if I do an update with one of those threads, after another one has done a pull, it's not going to have the latest version. So to solve this problem with my client anyway, what we did was we created an aggregation service or aggregation method, which we called the report assembler message listener. And so when each section is finished, what it would do is it would send a message to the report assembler message listener, and the report assembler message listener would be responsible for determining whether or not a report was complete, and if so, then putting it in the database, or otherwise, maintaining an internal state in its own queue. Now, it doesn't solve all the problems in the world, right? It's a very simple approach for the moment. You have to consider things like what happens if the server crashes. The report assembler is maintaining something that's by the implementation I'll show you here, it's in memory, so you would lose the job states, all that stuff, right? But because we're actually managing the status of the report, and eventually we would be updating the status of a section, you could theoretically do a cleanup process I wouldn't say easily, but you could do a cleanup process, because things would be stuck in a processing state or in an error state, which you could then run a separate job over to flip back to a pending state. Okay, but let's not worry about all the individual edge cases for the moment. Now let's see how far we can get with the last section, which is the report assembler. So the first thing I'm going to do is I'm going to create a report assembler. So I'm going to take this, and for convenience, I'll add it to this. So in my project, I'm going to do the same thing, another class, another message listener, again, and this message listener will have this definition. We'll have a close look at how we do this. Now, again, this is just one of n options you have. But what we chose to do, switch this to JRE7 so I can do a switch on strings. Message listener, receive, do receive. Same pattern, right? Now, in this case, what I'm doing is every section is going to send a message to my assembler, okay? Whether it's from report 1 or report 12, they're all going to communicate to the same listener. And in this case, what I'm doing is I'm only going to create a message listener with a size of 1. It's going to be a single listener, or one threaded pool, I guess you would call it, right? It could actually be a synchronous one in this case, but because I want it to be a non-blocking process, as soon as the section listener sends me a message, I want it to be able to die and be garbage collected. I'm going to leave this as an asynchronous process. Now, within this, what I'm going to do is I'm going to check the summary. And the summary that is being communicated to me is coming through the message that's sent from the section listener that has just run. And then based on the section that has come through, I'm going to set the status to be complete. Now, the important thing is here, what I've done is I have retrieved the report and I'm updating the model object. I haven't actually done any commits to the database. And when I do the get report, I've changed the logic slightly here, where I've said, you know what, I'm going to first check in a hash map that I'm maintaining locally here, and I'm going to see if the report has already been retrieved because another section has come in before, right? So if you imagine you have 5 sections in report A, the summary section comes in first. It will see that this map does not contain the report object, the database report object, so we'll go fetch it and put it in the map. The next section will come in, and it will say, give me the report, but because the report's already in the map, it's not going to pull the database record. So it's going to get the up-to-date version. And because we have a single threaded pool running in this case, you can only process one message at a time. We have no risk of multiple sections trying to update the same model object concurrently. Now, it just occurred to me that get, so what am I doing? If it contains key, then I want to get that. Yeah, if it doesn't, then what I should do is I should get the report. I can update the gist at the end of this call with the changes we're making here. This is the part I was saying I didn't really get a chance to fully flush out. So I'm just going to put it into the map. And the key is going to be the getter util.getString report ID, and the value is going to be the report. So if it's not already in the map, get it using the services that Service Builder gave me, put it into the map, and then return the report. Okay, so that's what's going to happen here. And then once I'm in this piece, I have my model object that I'm working with. It's fine. Again, this is all being done as part of the whole messaging infrastructure, though. Now, once I'm done with the statuses, I'm going to check and see if the report is fully assembled yet. And if it is, then I'm going to update it in the database. And if it's not, then I'm just going to put the updated report back into the map to make sure that the next thread that gets processed, when it does this get report, gets the latest version. Now, I'm going to determine whether or not the report is fully assembled. In this case, I just did a simple version where I just said, you know what, if all the individual sections have a status of complete, then you can set the report to be complete and you can return a Boolean value of true. If any of this is not true, so one section, for example, is missing or one section is errored, then you're going to return false. Now, this is a case where you know, you need to carefully consider what assembled means, right? Because technically, if I have a report where one of the sections errored, and I got a mistake, and I got a message saying that there was an error, and I update the status to have an error status, then that report would remain inside my hash table up here for the duration. And it would probably never be released because eventually all the section summaries would come in and my report would be fully updated, but not have the state that I'm looking for. But if for our purposes for today, we're going to assume happy path and everything works fine. You know, the basic point of using the message bus to communicate with a sub process to do the assembly is really what we're trying to demonstrate. Not so much all the branch logic around the conditions. Okay, so I've got my report message listener in place. I think this is where I stopped updating stuff, didn't I? Oh no, I did more. Okay, I need to update the create report message listener now. The change I'm going to make to it is going to be that I want it to start sending messages. So I'm not sure that I did that, but let's see. Yeah, this is kind of where I stopped. And I don't know that I fully tested this piece. So let's see how it goes. So what have we changed here? Well, for one thing, we're instead of letting the individual sections do the update, which they probably should, we're doing it in the create section. Now, really, this should not change to a status of processing until the actual listener that processes the summary starts working on it. But to do that, you know, requires again a little bit the table locks and, you know, synchronization, so on and so forth. Another option, which was definitely something that could have been done, is to make sure that this report is serializable as a JSON object, because the messages are basically allow you to add JSON objects to them. And then I could just pass the full report around and try and do some kind of a merge at the end in the assembler. But anyway, for today, let's just do it the cheating way and change the processing status, update the report so the table will have it set to processing for the entire report from the status through down to the sections. And then that's after the process. So at least I do it after I call them. Process section, and you can see here what's happening is I am again cheating. Hold on, this is the piece that's missing now. Okay, so the destination name in this case, well, it's fine. So that goes to the individual sections. This is the piece I didn't do. I'm sorry. So if I'll just do it for one to demonstrate. But the piece that's missing is at the end of processing the section, you need to do the same thing you do in the other listeners, and that is you need to create a message that goes to the assembler, right? So I'm going to add this. I'll probably rename it something a little more useful, like all assembler, and it would be after I get my response from the service, I would call assembler. I would pass it my, let's say, my report. I could pass it the section name and the listener class, which will be the report assembler listener class. And then down here, I'm just going to reuse the queue. Well, actually, I don't want to do that. I want to make sure that I only have one of these, right? So that I don't have any parallel concurrent conflicts. The queue can be left, so I can queue up as many as I want. I just don't want there to be any more than one of each that's happening. So I'm going to say creating for report assembly. And we should say this is report assembler. And it's not really a section specific one, it's just the assembler. I'll include the report ID. I need this, the section, I know that for sure, as well as the report ID, because in my assembler class, I'm referencing both of them in the do receive. Okay, now really I should probably put this into a base class and then have all these section summary listeners extend that base class so I don't have to repeat it, but you get the idea. Deploy and see if I can end up with any conflicts. Oh boy, that's a really bad one. I got caught right in the middle. Okay, I'll just do one more restart just to see if stuff we just did falls on the happy path for us. But then, you know, once that's done, assuming that we actually see the, you know, this thread processing inside our log output, then we know that we can reproduce this same approach for the other section listeners. And what we've done is we've now created not just reports in parallel, but individual sections of a report in parallel, and then put them all together at the end. And really, again, if you consider the whole demonstration today, how much code I had to write, you know, in terms of being able to leverage this kind of feature, which I think is pretty powerful, really, and without having to worry about things like thread leaks and, you know, pools and all the rest of it. You know, I think Liferay has done a pretty good job of providing the frameworks and the utilities that you need to do something that's kind of advanced, even if you don't have that kind of advanced knowledge. So just give this a second.
So, hey, Andrew, while we're waiting, I have a question.
Sure.
When the assembler, when the final report is done and assembled, is there some kind of callback to anything where you could like dynamically update a UI or a list of reports that are done, things like that?
Yeah, so that was, I actually took that out of the presentation, but there used to be a bullet here called bonus. and if we had another hour, I was going to demonstrate. We created a control panel portlet, and in the control panel portlet, we actually have an upgraded version of Tomcat where we're using the 5.2 version, or sorry, 5.3, and 5.3 supports WebSockets. So we created a control panel portlet that allowed you to view the jobs in their current state as well as when they were done, but then also a sub-process that would send you know, WebSocket notifications to the user to notify them that their particular report had been completed.
Nice.
And actually, the next phase, which we're about to try, is to remove not to remove, but to leave the scheduler as kind of a fallback for heavy load. And when the user actually submits a report request, throw it straight into the message bus infrastructure right away. And so what we're going to try and do is try and generate real-time reports, with a sort of 10-second counter, rather than having to wait and then 5 minutes later come back and check.
Cool. And one other question. What happens on a multi-node cluster?
This is the best part. This is the best part. I wasn't sure when we first started doing this, to be honest, but the scheduling process in Liferay does not run across multiple nodes. It's isolated to a single node. So you don't get the parallel in terms of infrastructure. The parallel processing is limited to one node in your cluster, but the one benefit that you have is that if something happens to that node and it goes down, then one of the other nodes in your cluster will automatically pick up and continue where that one left off.
Nice.
So that failover, again, which could be pretty complicated to build on your own, is kind of given to you for nothing.
Cool.
So, but actually, one of the guys on my team was complaining about the fact that it didn't run across all the servers. But really, for us, the bottleneck was not Liferay or our cluster. The bottleneck was the services that were producing the data not being able to produce it fast enough for us. So, we do at some point hope to maybe have a look and see if it is possible to have the parallel stuff run on multiple nodes in the cluster. But it's a whole new level of complexity at that stage, right? Because how do you know that one report is going to be processed on one node, and so on and so forth. So I'm just trying to see. I've deployed it again, and if somebody sees it, there it is. Report assembler. So you can see the assembler being called. So that's. Like I said, it's never going to show the done status because I have to do it for all the other section listeners as well, and then put in the final logic to do the final write to the database. But I think the idea has been demonstrated of how you would possibly do that. The alternative, of course, as I was saying at the outset of the talk, was we haven't tried it yet, but would be to use the callback feature. And the reason we didn't do that was because we didn't want a create report process to be blocked waiting for the callback to come in. And I don't think that would actually happen because of the asynchronicity. But just to be sure, for now, we've just pushed forward with the more of a shotgun approach rather than the callback.
Okay. I don't see any questions on IRC, so and we're also an hour and a half in, so we probably lost a bunch of people.
Right.
But I really appreciate the time. It's a very interesting subject, especially when you talk about dynamically updating UIs like the WebSocket thing you mentioned, and the multi-node clustering fallback or failover is really a nice feature that you get for free through Liferay. So,
Yeah, definitely.
Any closing comments or?
Yeah, no. I mean, those two things are great, but I personally think that the thread pool management and all those other little pieces that can lead to huge headaches in terms of application maintenance and performance are also things that you get kind of for free just by making sure that you use the Liferay utilities.
Okay. Well, I guess if we have no other comments, I see a comment from Jack Becker. This is heavy duty, lots of learning along the way. Yeah, this is one where you probably have to watch it a couple times and kind of follow along to, fully absorb everything. So it's kind of nice that the recording will show up on YouTube in about 4 minutes and be there for eternity. And the website will have the pointers to the material, like the fake service and of course the gist that you created. So that's awesome. And if you want those slides you created, just send them to me and I'll add them to the website as well.
Sure.
Okay, so I think we're done for today. Thanks again, Andrew. Always a pleasure to have you on. And so we'll close for today. We still have a session from Kamesh Sampath he had some scheduling issues with travel and work and stuff, so we had to cancel his back in April. But I promised him we'd leave it on the docket to get rescheduled. So that's a really good one on workflow. I know that's a very popular topic, and we have a bunch of other material that we're just trying to find a time slot to do. It's starting to get quite busy in the world of Liferay from now till the end of the year. So we'll find some slots to do. And also, I don't know if you saw this announcement, but Liferay Screens was released today. So we're very happy in the community about that. So if you want to check out what that is, it's a native developer toolkit for building native mobile apps using Liferay for iOS and Android. For more information, you go to liferay.com/screens, SCREENS, and you can check that out. That was released today. So again, we'll close for today. Thanks again, Andrew, and hope everyone has a great week, and we'll see you next time. Bye-bye.